Hello everyone, my name is Gurjot and welcome to stage 2 of the Retail Store Data Pipeline Proof of Concept project. If you have not already watched the project introduction video or stage 1, you can find the links in the description below. In stage 2 of the deployment, we will set up and configure an on-prem streaming data pipeline to process GPS location data. The items on today's agenda are the requirements for stage 2, the Dataflow Architecture, and a demo presentation. The requirements we will try to meet with this proof of concept are able to query multiple data sources, multiple event producers, multiple event consumers, and flexible code base. So now that we have our requirements, let's look at the Dataflow architecture. For this data flow, we will be utilizing the following technologies: MySQL, Postgres, NiFi, DBSim Connect, Kafka, Spark, and Superset. Step 1. NiFi will ingest data from the source REST API and write to MySQL. Step 2. DBSim Connect will allow Kafka to connect to the MySQL database and produce events. Step 3. Spark will connect to the Kafka broker to consume events and write to the Postgres database. Once the data is in the Postgres database, users can access it through Superset or other visualization tools. And to ensure that the solution can be easily redeployed, we will use Dockers. For the demo presentation, we will do a deployment using Dockers and a live run-through of the solution. You can find all the commands for the deployment in the README file on the GitHub repository. For our deployment, we will be using a VM with 4 cores, 16 gigs of RAM, 100 gigs of storage space, running RHEL 8.5 and Docker 20.10.13. Let's begin our deployment by cloning the GitHub repository and changing to the work directory. Please be advised that going forward, all Docker commands should be run in this folder to ensure that the volumes are mounted correctly. We can now start our deployment by launching the database containers and creating the initial databases. We will first launch MySQL and generate the database. Once MySQL is running, we will go ahead and launch Postgres and generate its database. And just like that, we have our MySQL and Postgres databases ready to go. Now that we have our database containers running, we can go ahead and start NiFi. Once we have confirmed that NiFi is up and running, let's go to the web UI and import the template. To import the template, right-click and select Import Template. You can select the XML file and upload. Now that the template has been added, we can go ahead and drag it to our workspace. Once the template has been added to our workgroup, you'll notice that there are 2 errors. These errors can be corrected by adding the password for our JDBC connector. To set the password, double-click Convert JSON to SQL, go to the Properties, then select the JDBC connection pool, and under Properties, you can set the password. Once the password is set, we can go ahead and enable the service. Now that the password has been updated and the services have been started, we can see that the warning message on the main page has disappeared. We now have the NiFi container started, the templates imported and added to our workspace. We will now deploy Kafka and DBSim Connect by first initializing the Zookeeper container. Once Zookeeper has been started, we can deploy Kafka and DBSim Connect. Once all the containers have been started, we can test that the Kafka broker is working. Now we will initiate our topics and confirm that it is currently running. We can now install the final containers by installing Spark Master followed by Spark Worker. Once Spark has started, we will go ahead and launch the Superset container. I forgot to record in the video, you will also need to add an admin user, upgrade the database, and initialize. Once everything has been initialized, the final container we will install is SBT so that we can build the artifact files. And now we can confirm that all our containers are running and healthy. Now that we have all our containers running, we can do a run through. First thing we will need to do is build our artifact file. To do so, we will need to run the sbt clean command first. Now that the build environment has been cleaned, we will go ahead and build our artifact file by running the sbt assembly command. Once the artifact file has completed building, we will go ahead and copy it into our jar folder to the Postgres database. Once the data has been written into the Postgres database, the user can access it by querying using any tool such as Superset. Thank you for watching this proof of concept presentation featuring a on-prem streaming data pipeline.